So we have the solutions to calculus homework number 18 from the textbook, and you can see that it's page 36 through 38 and these 5 problems. So starting with number 23, figure 1.56, which is this plot here, shows supply and demand for a product. So supply is this one that's increasing, demand is the one that's decreasing to the right. What is the equilibrium price for this product, and at that price, what quantity is produced? So I'm simply going to look at my graph and see where these two meet, because that is my equilibrium price and quantity. So at the equilibrium point that I'm indicating here, I have a price of approximately 10 per unit. So that's my price. And for my quantity going down, that appears to be, I'm going to assume, 3,000. So simply reading from the graph where your equilibrium point is. For part B, we want to choose a price above the equilibrium price, for example, P12. So that is this right here. So at this price, how many items are suppliers willing to produce? So I'm going to take from my graph on the supply curve, goes straight down, and this gives me suppliers would want to do about 3,500. And then how many do consumers actually want to buy? So that would be here where we cross the demand curve. So that would be approximately 2,500. So using these answers, we're going to explain why, if prices are above the equilibrium, we tend to go lower. Well, let's see. There's a lot of items compared to how many people actually want to buy. So this is what we would call a shortage, right? There is, sorry, not a shortage. I guess we should say surplus, sorry. A surplus, where we have more items than we actually want to buy. So the suppliers don't want to make a lot of extra that they're not going to sell. So therefore, they'll start selling lower. They're going to decrease this price. The people who are buying would happily buy if they had a higher price or a lower price. So the demand will go up when the price actually decreases. So for C, we're actually going to be looking at the same thing, but with a price below equilibrium. So that would be somewhere along this line. So they suggest P equals 8. So at this price, how many items are suppliers willing to produce? Well, the supply curve over here is now at the 2,500 mark, while the demand has changed to approximately 3,500. So in this instance, we have, like I tried to say last time, a shortage. There is too little product out there to purchase, so we actually have a higher demand than the amount of stuff we can actually buy. So that means that the suppliers, yeah, they're going to make more, but they're going to capitalize on the fact that people really want to buy their product. So they're going to be increasing price to get to that equilibrium point, since they're trying to fill a demand. But not everybody's going to be satisfied with the higher price, so demand will actually decrease a small amount when they go to that higher price. Moving on. Number 24 gives us two tables that present supply and demand. So we're going to say that this is going to be demand, as you can see, because price goes down as quantity goes up. And our second table will be supply. Price is going up as our quantity goes up. So why do we know that? Well, again, we're looking at how it changes over time. So we see that price and quantity are inversely related. If you have a demand curve, right? The higher the price, the lower quantity you're going to sell. So they're inversely related for demand. And they are directly related, or they're proportional, if you have supply, right? People will want to make more to sell if the price is higher. So we have a positive slope in that case. For B, at a price of $155, how many items would consumers purchase? So this is my demand curve. So I would say, all right, between $167 and $153, we have the price of $155. So we need to assume that between any 2 points on these tables, we have a linear relationship. Otherwise, we're not going to be able to do this very easily. So between $167 and $153, so we're going to do a little change in price here. We're trying to find the slope. So we're going to do 153 minus 167 over 15 minus 10. And so if I just pull a calculator out and calculate this, between these 2 points, we're going to say that you have a slope of negative 14/5, or if you actually do this with decimals, about negative 2.8, and that's going to be dollars per, we'll say, quantity. And so what that means is, if I go from 10 up to 15 for each one additionally that I sell, I would have negative $2.8 per quantity. So in this particular situation, if I'm looking for something that's 155, this relationship doesn't help me too much. I actually want to flip it around because I want to know about dollars. So I want to know how many I'm selling per dollar. So I could just estimate, since you really can't have a quantity that is not a whole number, and basically just estimate or approximately say that you're going to be selling not 15, just one less than 15. So you'll say either 15 or 14 items. So probably the 14, you'll probably want to lowball that one. So the same thing will be true for the other side of this. How much would they supply? So here we have a little bit of a larger gap. So we have a change of 166 minus 110 over 25 minus 20. And so putting this in a calculator, we have 56 divided by 5, which is approximately 11. So it's about 11.2, and that's dollars per quantity or per item, basically. And so if I want to figure out where the $55 mark is, since the step is about 11, then I'm going to be one item less than this 25. So a good estimate here is about 24 items. For D, will the market push prices higher or lower than 155? So now we compare these two things. So C, so we'll actually start writing D over here. So C is from the supply side, while B is from the demand side. And so if we look at this, supply is producing a lot more items than demand. So if we think about this from a plot standpoint, so we have price on the vertical, quantity on the horizontal, then supply should be doing something that looks like this. Demand should be doing something that looks like this. So supply, demand. Our supply is much higher than our demand. So here's supply being higher than demand. So we are above the equilibrium point in price. So what that means for us is we are going to be pushing prices lower in order to get to equilibrium. So price will decrease to go to equilibrium. Because we have a surplus going on. Now, the next two questions kind of go back to the same deal. It says, what price would you have to have if you wanted consumers to buy at least 20 items? So, in order to really think about this, we want to look at the demand curve. We want to look at about what price you need for 20 items, and so this is just quite simply $143. For F, again, now we want to look at supply side of things. So to supply at least 20 items, we would do $110. And that's really all E and F are talking about, just reading it from a standpoint of what does it mean to have a certain price for each of these two curves. 25. So we have a company that produces and sells shirts. The fixed costs are $7,000. The variable cost is $5 per shirt. And we're going to say the shirts for part A are sold for $12 a piece. So we're going to create a cost and revenue function as functions of the quantity of shirts. So we know for our cost that we have fixed cost plus variable cost. And so for us, our fixed cost is $7,000 and an additional $5 per shirt we sell. So this is our cost function for our shirt. For revenue, it says we're selling them at $12 each. So we're only going to be making $12 per shirt we sell. And that's all there is to the cost and revenue functions. Now B goes on to say, all right, we're going to change the price of the shirts. So the price of the shirt is no longer necessarily $12. We know that demand is given by 2,000 minus 40p, tells us how much we're going to be selling. What quantity would be sold at the current price of $12? So here we can just say, all right, if our price is $12, what is Q? So I'm just going to go ahead and substitute 12 for our price. So 2,000 minus 40 times 12 gives me a quantity of 1,520 shirts. Now, what profit is going to be realized at this price? Well, if Q is 1520, our profit would be given by, so we'll say this is profit as a function of Q, is given by our revenue minus our cost. So our profit, if we plug in 1520, would be our revenue, which is 12, times Q, which is 1520, minus 7,000 plus 5 times 1520. So our profit for this particular number of shirts would be, once we go into a calculator here, we get a profit of, we'll assume in dollars, $3,640. Now, C says, use this demand equation to write cost and revenue functions as functions of the price P. So, how do we do this? Well, Q, which is our demand function here, which is the quantity as a function of P, we will just simply sub into our cost and revenue functions for Q. So C of Q was 7,000 plus 5Q. So C of P would be equal to C of Q of P. So that's simply going to be 7,000 plus 5 times our Q function, which is 2,000 minus 40p. And this gets rid of the Q in our cost function. So this simplifies to, one step at a time, 7,000 plus 10,000, I'm distributing the 5, minus 200p, or, once we simplify this, simply 17,000 minus 200p. So this is our cost as a function of price. Our profit function would be the same way. Or, I'm sorry, our revenue function. So revenue as a function of price would be revenue as a function of Q of P. So this is simply going to be 12 times 2,000 minus 40p. Or, if we simplify this, simply 24,000 minus 480p. So that is our revenue function. Now we want to write the profit function as a function of price. So profit as a function of price, we can just say is R of P minus C of P, because profit is simply revenue minus cost. So for us, we've already made revenue as a function of price and cost as a function of price, so we can just put those two together. So our profit is going to be 24,000 minus 480p, so this is our revenue, minus our cost, which is 17,000 minus 200p. So make sure you put this in parentheses because you're subtracting the whole function. And so our profit function, if we simplify this, simply becomes 7,000 minus 280p. Now, for part D, it says graph profit against price. Find the price that maximizes profit. So, we actually have an interesting situation here where we have a problem. And that is this, that when we made our revenue function, we assumed that the price was still $12. Because in actuality, revenue should be price times quantity. So in actuality, our price is not $12, and this is in fact incorrect, which makes our profit function incorrect. So we actually have to go back into this and say that revenue as a function of price is simply quantity times price, which gives us a little bit of a different price or revenue function. It's actually going to be our quantity, which was 2,000 minus 40p, times p, which is our price. So we actually end up with a revenue function of 2,000p minus 40p squared. So that our profit function, which is still revenue minus cost, becomes a little bit more complex and would just be revenue, which is 2,000 times p minus 40p squared, minus 17,000 minus 200p. So our profit function should actually be, if we simplify this, negative 40p squared plus 2200p minus 17,000. So we have a much more complicated profit function. Now this actually goes ahead and helps explain why we were having trouble getting D and plotting this graph. So if I go in to my calculator and I plot the function negative 40 times x squared plus 2200 times x minus 17,000, I get a plot that looks like an upside down parabola. So we'll switch back to the other color. And waiting for this. So we do have a downward facing parabola, or a concave down parabola, we would say. And the profit function as a function of price will look something like this. Actually, we probably need a little bit more axis. So we end up with something that looks rather large. It looks something like this. And so we actually want to maximize the profit for which this occurs. So now we just go into our calculator and we maximize this function. So we can do it a couple different ways. I have a tool that actually lets me maximize it, so I will go ahead and use that tool. You can use whatever tool you want to. You can use the plot that you created to maximize it. But I get a maximum that occurs when the price is $27.5. So if you do this and you don't get a maximum of about $27.5, please let me know. 26. When the price P charged for a boat tour was $25, the average number of passengers per week was 500. When the price was reduced to $20, the average number of passengers increased to 650. What formula would we have for the demand curve, assuming it is linear? So our demand, we're going to say, is price as a function of numbers of passengers. So how does this work? Well, let's think for a quick second. Demand on a PQ plot would look something like this. And so we want to look at the difference or the slope between two different points. And the first point we had was a higher price and a lower number. So we'll say it is 500, 25. And our second point, which was a lower price but a higher number, would be 650, 20. So the slope of our PQ, or our demand curve, is going to be, so we'll say this is slope first, rather. So the slope of this curve, if it's linear, is going to be 20 minus 25 over 650 minus 500. Which we can probably do pretty easily, negative 5 over 150. And so the slope of this is quite simply 0.0333, repeating on and on. So we can just say that P is equal to negative 0.0333, rounding, Q, plus, we need to find an intercept here. So when would this intercept be 0? So we'll say this is our P naught, or P0. So let's use one of our points to find this. So I'll go ahead and pick the first point and say when we have a price of $25 with a slope of negative 0.0333 times our quantity of 500, this will give us a P0 of 41.667. 41.67, we'll say. And therefore, our actual function in the end is going to be P equals negative 0.0333 Q plus 41.67. And that's all there is to 26. For 28, we're given two different functions, a demand curve and a supply curve. A asks us, at $100, what quantity are consumers willing to buy and what quantity will we supply? So we have, for demand, Q equals 120,000 minus 500. For supply, we have Q equals 1,000 P. And so at 100, or a $100 price point, for demand, we would have 120,000 minus 500 times 100. So 500 times 100 is, of course, 50,000. So our quantity demanded is going to be 70,000. While our supply will be the same thing but with our supply function, which is 1,000 times 100. So this would be 100,000. And that's our two numbers, so let's compare these. So the quantity demanded is less than the quantity supplied. So if we're thinking about a supply and demand graph, that means we have a surplus. Therefore, the price will decrease to get to equilibrium.